Hello everyone. We will now begin our study of the second form of a conic section, which is the hyperbola. Now, just like in the ellipse, the hyperbola also has two foci points, two vertices, also a center point, but in addition, the hyperbola has a set of asymptotes. We will look into the shape of the hyperbola and then the standard form of the equation of an hyperbola, and then how to go about graphing hyperbolas. Here are the topics that will be covered in this lecture. We will begin by locating a hyperbola's vertices and foci, and then go into writing equations of hyperbolas. First, in the standard form, we will use the equation in standard form to graph hyperbolas centered at the origin. And then we will look at the equations of hyperbolas which have transformation involved in it. In other words, those hyperbolas will not be centered at the origin, just as in the case of the ellipse that we studied before. And then finally, we can look into some applied problems involving hyperbolas. Let's begin by studying the definition of a hyperbola. But before that, let's visit this figure on the right-hand side where they have graphed a hyperbola. Hyperbolas always come in pairs. The shape of the graph of the hyperbolas is arc-shaped, facing outwards. The graph has two focus points located on the x-axis, but in the outer region of the graph. The graph has vertices, just like in the case of the ellipse. The vertices are points on each of the hyperbolas, and the line segment that connects the vertices passing through the center point of the xy coordinate plane is known as the transverse axis. Now, by definition, a hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called the foci is constant. Therefore, whereas in the ellipse it was the sum of the distances from two foci that was constant, here it's the difference of the distances from the foci that is constant. Therefore, in the equation of the hyperbola, you can expect a minus sign because of this difference of the distances. Let's review the different features of the hyperbola a little more closely. We already said that the hyperbola graph comes in pairs. They are pretty symmetrical and they have two focus points in the outer region of the graph, and the focus points are located on the x-axis when the equation is in standard form, and the straight line that connects the focus points pass through the hyperbolas, and the points where the line meets the hyperbolas are known as the vertices of the hyperbola. So vertices are located on the graph themselves, but the foci or the focus points are outside of the graph. The line segment connecting the vertices that pass through the center point is known as the transverse axis. Therefore, it says the line through the foci intersects the hyperbola at 2 points called the vertices. So this is the line segment connecting the two purple dots, which are the focus points. They pass through the hyperbola, and wherever it meets the hyperbolas, those points are known as the vertices. The line segment that joins the vertices is the transverse axis. So just this segment of the line between the two vertices. And then the midpoint of the transverse axis is also the center of the hyperbola. We will now look at the standard forms of the equation of a hyperbola. Now, depending on the positioning of the hyperbolas, there are two different equations to use. When the hyperbolas are positioned such that they intersect the x-axis, the corresponding equation is x squared divided by a squared minus y squared divided by b squared equals 1. Again, the right-hand side of the equation is always 1 because it's a constant value. And here, for the hyperbolas, we have a minus between the two terms on the left-hand side, whereas in the case of the ellipse, we had a plus between the two terms. When the hyperbolas are positioned such that they intersect the y-axis, the corresponding equation is y squared divided by a squared minus x squared divided by b squared equals 1. All right? Let's look at the graphs of the hyperbolas in a little more detail. We see the two different positions of the hyperbolas here. One of them has the graphs intersecting the x-axis, and the graph on the right has the hyperbolas intersecting the y-axis. They open up and down in the second graph, whereas in the first graph we see that the hyperbolas open sideways, one to the left and one to the right. All right. Now, regardless of the positioning of the hyperbolas, the vertices will always be located on the axis and on the hyperbolas, and the variable a will identify where the vertices are located. Negative a on the left hand side, positive a on the right hand side if the graph intersects the x-axis. If the graphs are vertical, that means if they intersect the y-axis, then in the graph below it's negative a, in the graph up it's positive a, right? So the vertices are a units from the center and the foci are c units from the center. Therefore, A and C will always be on the axis which the graphs intersect. Now, for both equations, b squared equals c squared minus a squared. Equivalently, c squared equals a squared plus b squared. So these are the two equations we will have to note to find b. B will represent one of the denominators in our equation. Another thing to note about these graphs is that they are open-ended. You see over here, the graphs on either side have arrows marked at the ends, correct? Which tells us that the graphs increase indefinitely and decrease indefinitely as well. Now, the lines along which the graphs increase to infinity or decrease to negative infinity are the lines of asymptotes. Therefore, another exercise in graphing hyperbolas is to locate the position of the asymptotes, and that will be one of the steps in the graphing process of a hyperbola. Right? Let's work on an example to find the vertices and foci of a hyperbola given the equation. The question says, find the vertices and locate the foci for the hyperbola with the given equation, which is x squared divided by 25 minus y squared divided by 16 equals 1. Let's write out the general form of the equation first. It's x squared divided by a squared minus y squared divided by b squared equals 1. Now, the form of this equation where x squared divided by a squared is the first term and a squared is aligned with x squared tells us that the graphs of this hyperbola will open sideways, not up and down. So let's identify the values of A and B, because A will represent the location of the vertices of the graph, and then foci is represented by the C coordinate. However, we will need the value of B to calculate C and therefore get the answer for the foci. All right. So if A squared equals 25, then A will be equal to plus minus 5, correct? And if B squared equals 16, then B will be equal to plus minus 4. Now, given that, let's go on to solving the problem. I'm going to pull up the solutions here. They have identified A squared first, which is 25, followed by the value of A, which is plus minus 5. Therefore, the vertices of the graph will be at negative 5, 0 and positive 5, 0. That means the distance from the point of origin to each of the vertex on the x-axis will be 5 units. All right. And now we have to find the foci of the graph. To find the foci, we will use the formula c squared equals a squared plus b squared, right? So c squared equals, plug in the value of a squared, which is 25, plus b squared is 16, equals 41 when we sum that up. Therefore, c is plus minus square root over 41. That's the value of the foci of the graph, right? So here they have drawn a picture of the graph as we had expected. The graphs, they open sideways and the vertices are at negative 5, 0, negative 5, 0. That's the point here. The vertices are located on the graph, and positive 5, 0, and then the foci will be at negative square root over 41, 0, which will be somewhere here between negative 6 and 7 and between positive 6 and 7, somewhere here, right? So now we have found the vertices and foci from the equation given to us in standard form, and also have shown the graph as well as the vertices and the foci using the information that we found. Here's another example of finding the vertices and foci from a hyperbola's equation, but this time the equation given to us will have the graph of the hyperbolas opening up and down. You can tell that by looking at the equation given to us. This time we have the y variable term first, followed by the x variable term. What is the form of the equation which will have the hyperbolas along the vertical axis? That's y squared divided by a squared minus x squared divided by b squared equals 1. Therefore, a will be equal to plus minus 5 and b will be equal to plus minus 4. All right. So let's go through the exercise of finding the vertices and the foci. Again, first we have to identify a squared, which is equal to 25, followed by the value of a, which is plus minus 5, which we got by finding the square root of 25. The vertices are therefore located at 0, negative 5. The vertices now will be located along the y-axis. On the y-axis, the x-coordinate is 0 and the y-coordinate will be negative 5 on the graph which faces down, and for the graph that faces up, the coordinates will be 0, 5. The next step is to find the foci of the graph using the formula c squared equals a squared plus b squared. Therefore, c squared equals, plug in the values of a squared and b squared, which is equal to 41, and therefore the foci will be the same as what we had for the previous example when the graphs open sideways. They'll be located at plus minus square root over 41. Therefore, the foci are at 0 comma negative square root over 41, because again the foci will be on the y-axis, and for the graph opening up it'll be at 0 comma square root over 41. So let's identify the points here. For the vertices are always located on the graph on the y-axis. So this is one of the vertex and this is the other vertex. This is one vertex up on the graph along the y-axis, and this is another one. So these two are the vertices, and then the foci will be located somewhere between -6 and -7 for the graph below. So this is one of the foci, and the other one will be between 6 and 7, somewhere here. All right, so the green ones, they represent the foci of the graph. All right, now example 2 is about finding the equation of a hyperbola given the coordinates of the foci and the vertices. The question says find the standard form of the equation of a hyperbola with foci at 0, -5 and 0, 5 and vertices of 0, -3 and 0, 3. Now right away, by looking at the coordinates of the foci and the vertices, we know that the hyperbolas will open up and down. They will intersect the y-axis. Why? Because we have a 0 for the x coordinate for each of these ordered pairs, right, for each of these points. So in order to solve this problem, let's look at the equation. The equation of the hyperbolas that open up and down is given like this: y squared divided by a squared minus x squared divided by b squared equal to 1. We have to find the values of a squared and b squared in order to complete the equation, correct? Now a will be determined by the value of the y coordinate of the vertex. In this case, it's -3 and +3. You just square that, so a will be equal to 3 squared, which is equal to 9. So we know the value of a squared, one of the denominators, which is a squared, will be y squared divided by 9. We have to find the value of b squared. But let's go through the solution given to us step by step. So solution says because the foci are located at 0, -5 and 0, 5, the transverse axis lies on the y-axis. Thus, the form of the equation is y squared divided by a squared minus x squared divided by b squared equals 1. That's exactly what we wrote up right here. All right. And then it goes on to say that the distance from the center to either vertex is 3 units. So a will be equal to 3. Therefore, a squared will be equal to 9. And I would like to correct this. I wrote here a equals 3 squared, which is not correct. It should be a squared equals 3 squared, which is equal to 9. A is equal to just 3. All right, and then we have to square the value of the a, in order to get the value of a squared. All right. Now we will need to find the value of b squared in order to complete the equation. So far, this is how our equation looks like. It's y squared divided by 9, which was the value of a squared, minus x squared divided by b squared. We do not know yet the value of b squared equals 1. Now we will find the b squared using the formula c squared equals a squared plus b squared, right? Therefore, let's pull up the solutions. We have c squared equals a squared plus b squared. In the next step, plug in the values that we know. C squared is 25, a squared is 9, and b squared is what we will be finding. Therefore, solving for b squared, we get b squared equal to 16. Now we are ready to complete the equation, which is y squared divided by 9 minus x squared divided by 16 equal to 1. All right. We will now learn how to identify the asymptotes of a hyperbola. Now, depending on whether the hyperbolas open sideways or they open up and down, the equations of the asymptote will differ. Now, if the hyperbola has the equation x squared divided by a squared minus y squared divided by b squared equals 1. That means they intersect the x-axis. They have a horizontal transverse axis. Then the two asymptotes are given by the equation y equals b divided by a times x and y equals negative b over a x. If the hyperbolas open vertically, in other words, the transverse of the hyperbolas are vertical, they intersect the y-axis, the equation of which would be y squared divided by a squared minus x squared divided by b squared equals 1, then their asymptotes will be y equal to a over bx, that's the equation of the asymptote, and y equals negative a over bx. Therefore, all graphs of hyperbolas will have a pair of asymptotes, right? We see two equations given to us. They will be pretty symmetrical, only that one will be a line which has a positive slope, the other one will be a line which slopes down. It'll have a negative slope, all right? Here's a graphical representation of the asymptotes for each of the two hyperbolas given here. As you know, each graph has a pair of hyperbolas. One of the asymptotes is the line which is y equals b over ax. That's the line that rises from left up to the right, and then the other one is a line that drops from the left to the right. The equation for that is y equals negative b over ax. Now, these asymptotes pass through the origin of the rectangular plane, and as you can see, it passes through the diagonals of a square. Now, this square passes through 0, comma b and 0, comma negative b, and then on sideways it passes through negative a, comma 0 and positive a, comma 0. And as x and y get larger, the two branches of the graph of a hyperbola approach a pair of intersecting straight lines which are called the asymptotes. For the hyperbolas facing up and down, it's the same, except that the equations of the asymptotes would be y equals a over bx, that's the line with the positive slope, and then the line which is dropping with the negative slope, the equation of that is y equals negative a over bx. Again, the asymptotes intersect each other at the origin, and they are passing through the corners of a square, and that square passes through 0, comma a. These dashed lines of the square are tangential to the hyperbola at 0, comma a and 0, comma negative a, and also crosses the x-axis at negative b, comma 0 and positive b, comma 0. All right? We will now go through the steps of graphing hyperbolas that are centered at the origin. We start by locating the vertices of the hyperbolas, for which we have to consider the value of a squared and thus obtain plus minus a. And then the next step is to draw the asymptotes. In order to do that, we start by using dashed lines to draw the rectangle centered at the origin with sides parallel to the axis, crossing one axis at plus minus a and the other at plus minus b. If you remember the diagram in the previous slide, there was a rectangle drawn between the two hyperbolas in each of the graphs, and we will use that rectangle to draw the asymptotes because the asymptotes pass through the diagonals of the rectangle, through the corners of the rectangle. And then number 3 is to use dashed lines to draw the diagonals of this rectangle and extend them to obtain the asymptotes. And number 4 is draw the two branches of the hyperbola by starting at each vertex and approaching the asymptotes. Let's work through an example of graphing the hyperbola using the steps that we learned before. The equation given to us is x squared divided by 36 minus y squared divided by 9 equals 1. What are the equations of the asymptotes? However, we will first start by locating the vertices of the hyperbola. For that, we have to consider the value of a squared. Now, in this equation, a squared is the denominator of x squared. Therefore, a squared will be equal to 36, a will be plus minus 6, and b squared has a value of 9. B squared is the denominator of y squared, which is 9. So b squared equals 9. Therefore, b will be equal to plus minus 3. Right, so let's go through the steps now. The first step is to locate the vertices. The given equation is in the form x squared divided by a squared minus y squared divided by b squared equals 1. Therefore, a squared has a value of 36, which is the denominator of x squared. B squared has a value of 9, the denominator of y squared. Therefore, a is plus minus 6. That's where the vertices will be located, minus 6, 0 and 6, 0. So this is a sideways facing hyperbola. The next step in the process of graphing a hyperbola is to draw a rectangle that passes through the x and the y axis, and that provides a framework through which the asymptotes will pass. Therefore, to draw the rectangle, we will have to consider the values of a squared and b squared. A squared equals 36, therefore a will be equal to plus minus 6. The rectangle will cross the x-axis at negative 6, 0 and positive 6, 0. And along the y-axis, it will pass through negative 3, 0, which is right here, and positive 3, 0. How do we get negative 3 and positive 3 on the y-axis? By considering the value of b squared, which is equal to 9. Therefore, b will be equal to plus minus 3. Therefore, the rectangle passes through the points minus 6, 0 and plus 6, 0 and 0, negative 3 and 0, positive 3. We have to connect these points. We have to draw a rectangle through these points with a dashed line, and the diagonals of this rectangle will eventually become the asymptotes of the graph. In step 3, we will draw the asymptotes by first drawing the diagonals of this rectangle and then extending them all the way through. The equation of each of the asymptotes will be given by y equals b over ax. B had a value of 3, a had a value of 6, which gives us 1/2. 3 divided by 6 equals 1/2. The equations for the asymptotes are y equals half x, that's the line going up from the left to the right. Y equals half x, it has a positive slope, and the other asymptote will be y equals negative 1/2 x. The last step will be to draw the hyperbolas along the asymptotes as well as the vertices. In step 4, we draw the two branches of the hyperbola starting at each vertex and approaching the asymptotes. Therefore, the hyperbolas given will have its endpoints extending along the asymptotes on either side, and it'll touch the vertices at minus 6, 0 and positive 6, 0. Now, c squared equals a squared plus b squared. C will be where the foci of the hyperbola would be located. We have to find that. So c squared equals a squared plus b squared. Therefore, c squared will be 36 plus 9 equals 45. So c will be plus minus square root over 45, which is approximately 6.4. Therefore, the foci are at negative square root over 45, comma 0 and square root over 45, comma 0. Now you can use your calculator to find square root over 45 and write it in ordered pairs like this, or you can just leave it as negative square root over 45 to define the coordinates. Now we will study the translation of hyperbolas and their respective equations. The equations of a translated hyperbola is given by x minus h whole squared divided by a squared minus y minus k whole squared divided by b squared equal 1. In this translated graph, the center will be at h comma k and the transverse axis will be parallel to the x-axis, horizontal. The vertices will be located at h minus a comma k and h plus a comma k respectively. All right. Now the foci are c units right and c units left of the center where c squared equals a squared plus b squared would be. All right. As for the hyperbolas opening up and down, the equation is y minus k whole squared divided by a squared minus x minus h whole squared divided by b squared equals 1. The center of that would still be h comma k, but the transverse axis would be parallel to the y-axis. In other words, it's going to be vertical. The vertices will be at h comma k minus a and h comma k plus a respectively. Again, the foci are c units above and c units below the center, where c squared is equal to a squared plus b squared.